Hey guys, I have a 5 minute limit on my video, so I ran out of time. So I wanted to show you how to do this with algebra, right? And I also wanted to point out that I adjusted the axes of my x and my y here because I couldn't see enough of this part for my next question, so I just had the graph the axes start at 1500 to give me more space so I can answer my next question. Also, to answer my first question, how big is a house that costs 75,000? It was about 2,200 on the graph, but I couldn't really tell exactly. So to solve for it, I had to use algebra. So what I do is I put 175,000 in for y, and then into my equation, right? Well, then I have to subtract 26,140 from each side, and that's how I get 148,860 equals 67.6x. And then what I do in the next step is I divide both sides by 67.6x, and what I get is 2,202 equals x, which means the house would have 2,202 square feet. So notice my estimate using the graph was really close. I don't do as well with the next one, right? My extrapolation question, which again means it's outside of my data set. Here's my last data point, and you notice 150,000 lies outside of that, so that is extrapolation. So again, it looks like it's about 190,000, but I can't tell exactly. So to solve for it, I put 150,000 in for y in my equation. And so then I subtract that 26,140 from both sides, and I get 123,860 equals 67.6x. I divide both sides by that 67.6x, and I get 1,832.25 square feet. So not as close to that 1900 that I estimated on the graph, but that is the answer. So that's my questions for extrapolation and interpolation. Finally, I wanted to just give you guys an example of what I expect for the paragraph. So I chose to analyze the square footage of a house price of the house and the price of the house in a subdivision, and I got my data from a math book, which makes it real nice. So this data shows a pretty strong positive correlation. And why I say the data is strong is if you look, none of my data points are too far away from my line of best fit. So that means my correlation or the relationship between the two things is pretty strong. And then the reason I say it's a positive correlation is the slope of my line is positive. So that means it's a positive correlation. So I also say that there is no outliers, and what that means is none of my data points look extremely far away from the others. If I had one data point like way down here, I might call that an outlier. And sometimes dealing with outliers, you can actually throw them out. Like you can remove that point of data from the rest of your data because it might throw off your results. But I don't have any outliers in this set of data, so I didn't worry about it. Also, what my equation means is if you look at it, y equals 67.6x plus 26,140. I talk about how that 26,140 is essentially the starting point. I'm assuming that is my cost of a piece of land. And then for each square foot of house that goes on that land, it raises the price by $67.6. So I explain what my equation means in terms of this example. I'm going to share this document and this video with you, so let me know if you have any questions.